Sometimes we have a fraction like this and we need to integrate it. So whenever we have a fraction where you can factorize the denominator, it's a good idea to start with partial fractions. This question is asking us to express this as partial fractions. So there isn't an integration method called partial fractions, but partial fractions is a method to simplify expressions and make it easier to integrate. So if we start by rewriting our fraction as three separate fractions or three partial fractions, I could express this as some constant a over x plus 2 plus b over x plus 3 plus c over x minus 1. Now what you want to do is form some expression that links this to the numerator. So we can use a common denominator and say a times x plus 3 times x minus 1 plus b times x plus 2 x minus 1 plus c into x plus 2 x plus 3, and all of that should be equal to our numerator x plus 1. So that's our expression, and we have three unknowns, three variables, a, b, and c. So, well, they're not variables, they're constants, but they're unknown constants in this expression. So one method of solving this is to take three different values for x and then try to solve for a, b, and c. So in order to find a, I'm going to take x equals negative 2, so that this becomes a 0 and this becomes a 0, and we can solve for a. So I'm going to say x equals negative 2, because if I were to put negative 2 here, I would have a 0, so that all becomes 0. If I put negative 2 here instead of x, I get 0, so all of that becomes 0, and I end up with an expression only for a. So I have a times negative 2 plus 3 times negative 2 minus 1 equals negative 2 plus 1. So I substituted negative 2 here, here, and here. So negative 2 plus 3 is 1. So I have minus 3a equals minus 1. So a equals 1 over 3. So that's my first constant. I've found the value of a. So that's my first win. Now to find b, I'm going to take x equals negative 3, so that this becomes a 0 and this becomes a 0, and I don't need to worry about this term or that term. So I'm going to say x equals negative 3, and then I've got b into negative 3 plus 2 times negative 3 minus 1. So I'm substituting negative 3 into x. And I'll do the same here. Equals negative 3 plus 1. So negative 3 plus 2 is negative 1. Times negative 4. So I have 4b equals negative 2. So b equals minus 1 over 2. So that's my second constant. I found b. And we do exactly the same to find x. In this case, to find c, I'll take x equals 1, because that will then be 0, and I can forget about all of these. So I'm going to take x equals 1. Then I have c multiplied by x plus 2 times x plus 3. So 1 plus 2, 1 plus 3. So 3 times 4 is 12, and that's 2. So I have 12c equals 2, so c equals 1 over 6. So now I found my three constants, a, b, and c. So I can write my answer using those three values. So I can simply write the expression as, I'm going to replace a, b, and c with the values I found, 1 over 3, negative half, 1 over 6. So 1 over 3, negative half, 1 over 6. That's the answer to the first part that says express this in partial fractions. So I can simply write that out like that. Now, it isn't good practice to have a positive sign and a negative sign, so I'll just replace the positive with the negative. All right, so watch out for that. So now we have this expressed in partial fractions. I haven't integrated, I haven't done anything, I've just rewritten it. So that if you were to add these fractions together, you would get that. So that's part A. Part B then asks for the integration, and it's a definite integral from 3 to 4. So it says hence, suggesting that really we wouldn't be able to integrate that without using this. So I can now rewrite my integration as the integration from 3 to 4 of 1 over 3 divided by x plus 2 minus 1 over 2 over x plus 3 plus 1 over 6 over x minus 1. So this is what I'm actually going to integrate, and it looks much easier now because basically you have three separate integrals, each of which we know how to integrate. Let me remind you that the integral of 1 over x dx is simply ln x plus c. So using that, it's fairly easy to integrate my three fractions. It's simply going to be 3 natural logs. So I can write the answer as 1/3 times ln x plus 2 minus 1/2 ln x plus 3. Let's move this along. Plus 1 over 6 ln x minus 1. And I'm not going to add a constant because it's a definite integral. We have these limits. So we don't add a constant. What we do is we put brackets and we put our constants. And then we can substitute x equals 4. And then we substitute x equals 3. And then we subtract. It's probably better if I simplify the logs, but I won't. I'll just put all of that in the calculator. So it's 1 over 3 ln 4 plus 2 minus 1 over 2 ln 4 plus 3 plus 1 over 6 ln 4 minus 1. So that's after substituting the 4, you now need to substitute the 3, but you need to subtract. So everything that comes after the minus sign is when we substitute the 3. So I'm going to do that all again, but this time we're going to have brackets. The brackets are important to make sure everything is subtracted. So I'm going to write it out again. 1 over 3 ln 4 plus 3 minus 1 over 2 ln 4 plus x plus 3, isn't it? So it's 3 plus 3. Sorry, so this is x plus 2, so it's 3 plus 2. And then it's x plus 3, so it's 3 plus 3. And then it's x minus 1, so it's 3 minus 1. Okay, so we can now, so that's going to be a 6, that's going to be a 7, that'll be a 3, that's a 5, that's a 6, and that's a 2. Now, unless they ask for exact solutions, for a question like this, you can just put it in your calculator. So I'll put it in to mine and see what I get. So as you can see, I put it in my calculator and it gave me 0.0513. So that is your final answer. Now, I know it looks strange, but because it's a definite integral, you're going to end up with a number, and that's your number. So that's how you integrate using partial fractions. So the partial fractions has made it easier for us to integrate, because each of these will give me a natural log. Each of these is a ln. So the trick was to separate this into 3 fractions and then use these constants here. These are the coefficients here. And make sure that when you substitute your limits, you subtract. So you first substitute the 4. So here we have the 4, the upper limit. And then you substitute the 3, and you make sure you subtract. Okay, so that was integration using partial fractions, and I hope you found that helpful.